Rusani,
Yes, sir.
how are you?
I'm good, sir. How are you?
I'm good. Mahlatsi,
Hello, sir.
how are you?
I'm good, thanks. And how are you?
Fine, what is Murisa?
Yes, sir.
Do you know what are hydrocarbons?
Huh?
Do you know what are hydrocarbons?
No, sir.
Hmm. Mahlatsi, do you know what are hydrocarbons?
No, sir.
Okay. Um, Rusan, tell us what are hydrocarbons.
There are compounds that consist of carbon and oxygen only.
Carbon and
Carbon and oxygen only.
nope. Oxygen. Where is the oxygen coming from?
How?
Carbon and hydrogen.
Yes.
It was a mistake, no?
Yes.
It's a bad mistake. But I'm gonna take it as a mistake. Yes, hydrocarbons are chemical compounds that are made out of carbon and hydrogen only, which are alkanes, alkenes, and alkynes. We have talked about them, and then we started talking about alcohols. We talked about alcohol, and then we know what are primary, secondary, and tertiary alcohols. So, it means that Modisa and Mahlatsi, you were missing classes. Yes, but I will send you videos that will explain those things to you that we have done, right? All the videos that we have done, I've been recording all the classes since I knew that some of you were on holidays and some of you were not available. So I've been recording all the classes. So I think now after this class, I will take some time to download all of them and post it so that you can watch them. All right. But hydrocarbons are chemical compounds made out of carbon and hydrogen only. So they are alkane, alkyne, alkene, and alkyne. So these are hydrocarbons. So we have passed the hydrocarbons. Now we've introduced the hydronium OH, right? We've introduced the hydronium, right? OH, hydrogen oxide. So this one is going to be part of the alcohol. This one gives us an alcohol. So I've introduced the alcohol that will end with anol. All right, anol. The alcohol will end with anol. All right, so that is going to be propanol, butanol, like fourth, like those, right? So that is what we call alcohol, right? So after alcohol, we've got another functional group. The other functional group that we're going to go to is going to be an and a ketone, right? It's going to be a ketone. So what is a ketone? A ketone is made out of oxygen. All right, when we've got oxygen, and then remember oxygen will bond twice. When oxygen bonds twice with carbon, this is a ketone. Out there.
Yes, sir.
Yes.
Okay. So this is a ketone. So remember, carbon will bond twice. So here is the ketone that I'm going to start with. It's going to be this one here. So that is our ketone. I'm sure I'm not, yes, that is our ketone. So this one here is either a ketone or aldehyde. So this one is not a ketone, it has to be an aldehyde. So let's not have it. So let me just have a ketone. Here is the ketone. Yes, here is the ketone. Yes. That one is, this is a ketone. So if the oxygen at the end there, the carbon at the end there is the one that have got an oxygen. It is no longer a ketone. So ketone will start only with 3 carbons. There's no ketone with 2 carbons. Ketone will start with 3 carbons. So the first one is going to be what? Ketone. They end with 1. All right. They end with 1. All right. So because it's a what is 3. 3 is what? 3 is propan or 2. It's on the number 2. 1. All right. Propanol. So it's going to be called propanol. All right. This one is called propan 2,1 or propanol or 2-propanol. All right. So you can name it like this because the 2 is the position. All right. The 2 is the position of um of our functional group here. It's on carbon number 2. The 2 is for the functional group, which is on number 2. All right. So this one's going to be called propan 2,1, or someone can just name it. Can just name it 2. Propan. No. Right. 2-propan-1 or 2-propanol. All right. So now someone can name it like this, or someone can name it like this. They are both correct, right? But remember, you have to mention that where is the functional group that you're naming it a 1, all right, which is a ketone. So ketone is on carbon number 2. So this one is going to be called propan 1, propan 2,1, right? Or propan 2,1. Yes, it's propan 2,1 because it's on the second carbon, all right? And then we can have another one, which is going to have 4 carbons. 4 carbons. So this one here is our functional group where we've got our 1 there. So it's already is on also is on number 2 there. All right. It's still on carbon number 2 there. So it's on carbon number 2. So this one, because it's 4, so it's going to be butan. Butan is on number 2. Butan 2, 1. All right. So it's going to be butan 2, 1. All right. So it's going to be, or some can call it 2 butanol. All right. So remember, when we go forward, once you understand this topic completely, you are just going to call it butanol, because butanol, because you understand later why there's no need for you to give the number. But for now, I just want you to understand it as if you have to give the number every time, because giving a number doesn't deduct any mark, but leaving a number where it is necessary, they will deduct a mark. So here it was not really necessary, but I don't want to teach you that you should leave it, because you will end up leaving it where it is very necessary. All right. Why am I saying it? There was no need. It means that this OH here, this O here, double bond of O, could have stayed here. And if it was here, then the name was still going to be true butan 1. All right, because it is still on carbon number 2. If we start counting from this direction, here we started counting from this direction going to the left, because this is the closest part to the functional group. All right, that was the closest part to the functional group. Sorry. So that is what you need to understand. All right. So this one is called butan 1. All right. So this is a ketone. So there is something called a aldehyde. All right. There is something called an aldehyde. Aldehyde is the same as ketone. Aldehyde. Aldehyde is the same as ketone. It's just that the oxygen bonds with the carbon that bonds with H. So you can see that this carbon here doesn't have an H to bond with. It bonds with 2 carbons and oxygen. All right. But in this aldehyde, it means that the carbon that bonds with O, it have bonded with another H. What does that say? It says that the O is on the last or first carbon. All right. The functional group of O is on the first or last carbon. So for an example, this one here, we can see that we've got only 1 carbon. so it's on the last. So I told you that this one here cannot be a ketone. This one is an aldehyde. So this they end with al, right? Anal, null. They end with null. Butan, null. Butan, null. Yes, they end with al. Yes, they end with al. So this one, because it's meth, it's going to be called methanal. All right, it's going to be called methanal. All right, this one is going to be called methanal. And then when we've got two of them, it's going to be called sorry, ethanol, right? Because it's two, is eth, so it's going to be ether. Now, there's no need for you to give a number on the aldehyde because obviously the O will be at the first carbon, right? And then this one here is going to be called is three carbons. Three carbons means prop, so it's going to be propanal. Right, so because this one is at the first carbon, so you see propanol, this is an aldehyde, but if this O was not on the first carbon, was on the middle carbon, it was not going to be an aldehyde, it was going to be a ketone. So this is 1, 2, 3, and then if O was here, then it was going to be what? It was going to be a ketone, which is propan, propan 2, 1, right? Propanone, all right? So it was going to be propanone, right? Propan 2, 1. So this one is a ketone. This one is a ketone. This one is an aldehyde. So ketone and aldehyde, the only difference is the position of O, right? Is the position of the functional group, which is O. So that is the difference between a ketone and an aldehyde, right? Oh, clear?
Yes, sir.
Yes, sir.
Yes.
Okay, and then there is a mixture of this functional group and an OH group. OH, remember, is an alcohol, all right? So that one is going to be called an carboxylic acid, all right? The one that we're going to is going to be called carboxylic acid, and then it ends with oic acid, all right? It ends with oic acid, all right? So carboxylic acid, all the time carboxylic acid it will have, okay, so I will start with the first one. So here is O, and then here is our OH, and then there will be our H, all right? So this one is going to be number one carbon is a meth, all right? So this one is going to be methanoic acid, all right? So they end with oic acid, all right? Those are carboxylic acids when we've got this functional group and carbon on and OH on one carbon, all right? They will never be separate on different carbon. They will always be in one carbon, all right? So that is what you call oic acid. They are called carboxylic acid. This one are called carboxylic acids, all right? These ones are called carboxylic acids. So another one is going to be this one here, which is on number 2, right? OH there, and then H, and then H, and then H. So this one is 3. 3 is eth. So this one's going to be ethanoic acid. There is no need for us to name the position. So this one is just an ethanoic acid. It's a carboxylic acid. All right. This one is a carboxylic acid. So these things are all very, very important. So the only functional group that I didn't talk with is ester, because when you talk about ester, we will start by esterification, or can I just give you an ester. Okay, I'll just give you an ester also. So this one you can see that is called ethanoic acid. All right, is this one is an ethanoic acid. It's a carboxylic acid, right? This one is a carboxylic acid. It ends with oic acid. So even if we've got 5 carbons, and then the last one or the first one will have something like this, then it's an carboxylic acid. Yes, so this one is a carboxylic acid, and how many carbons is 5? So it's going to be pent because of 5 carbon. So it's going to be pentanoic acid. So this one's going to be called pentanoic acid. All right. So this is very, very important. Carboxylic acid. So we all know hydrocarbons. Hydrocarbons. So hydrocarbons, we've got alkane. Sorry, we've got alkane, alkene, and then alkyne. All right. And then we have alcohols that we see by OH, right? By the bond of OH. Alcohol, we see them by OH bonding with carbon, all right? And then we can have our ketone, where we know carbon will bond with oxygen, all right? And then ketone, it means that this cannot be H and cannot be H somewhere here, because if there is H there, then it is no longer a ketone, it's going to be an aldehyde, right? And then we know we've got an aldehyde, aldehydes, which is going to be O bonding with C. The C that the bond O bonds with should bond with hydrogen because it's the last C or the first C, all right? And then we have a carboxylic acid. Carboxylic acids. So carboxylic acid, we see them by the carbon that bonds with O and then OH. So there is the carboxylic acid. All right. So those are the functional groups. So here alkane, we know that we've got only one carbon bond, and then alkene is when we've got double bond, and then alkyne is where we've got triple bonds, right? So those are the first basics that we need to understand about organic chemistry. All right, those are the first basics that we need to understand about organic chemistry. It will be much easier for us to name all the chemical compounds if we understand exactly what I've just taught you from the first lesson, right, of organic chemistry. You will be able to name all these. And then I talked about primary, secondary, and tertiary alcohol, but if you were not here, then you will see the video, right? But we talked about all the alcohol, different alcohols, and all the stuff, right? So and then we've got carboxylic acid, yes, and then the next thing that we're going to have is going to be an ester. All right, ester, you see an ester by having an an oxygen, that you have got carbon this side and carbon this side. That's the first thing that you see an ester. You see, you know, we usually we're having O bonding with carbon twice, right? But now this O, it bonds with 2 carbons, right? So that is an ester. And then you can say this is a bridge. So this is going to be another chemical. We can have chemical compound and other chemical compound, and then they come from the reaction called esterification, but we'll do it when we do reactions, right? But this is an ester. We see an ester because I'm going to have an OH somewhere here, OH somewhere there, and then C, and then on the other side I'm not going to have OH. All right, so there is our ester. there is our ester. All right. So when we name an ester, okay, so let me have 3 there. When we name an ester, you see, this one is it looks like an alcohol because it's going to have OH there. And then this one here, it's just a hydrocarbon. It's fine. So we start by naming a hydrocarbon as if it was a branch. All right. So because the first branch here, this branch here, it have got 2 carbons, right? It have got 2 carbons here at the beginning. So these 2 carbons here is going to be eth. All right. So I'm going to name this one ethyl. All right. And then this one, because it have got an alcohol there, it's going to be called OIT. All right. So this one's going to be called ethyl. And then this one is prop because it's going to have 3 carbons. So it's ethyl propanoate. So this is how you name it. You see, the other branch will never have OH, and then the other one will have OH. The one with an OH we're going to call OIT. All right, OIT. See the name here, OIT. So the first one is just an ethyl. Ethyl, the same way when we were naming the hydrocarbon, the branch is, it ends with YL, methyl, ethyl, butyl, like so, right? So that is what we call this one. It's an ethyl propanoate, right? This one is an ethyl propanoate. So again, I can have it like this: 1, 2, sorry, OH, O, 1, 2, 3, 4, 5. Yes, let's just have it like this. Yes. So all here is just hydrogens, right? It's just hydrogens throughout here. So when we name this one, where are we going to start? Remember, the side with an OH is going to end with OIT, right? So we cannot start with an OIT. So it means that when we name this one, we'll start with the other half after the bridge. So this is our bridge where the O is. So on the other side, I've got 1, 2, 3, 4, 5 carbons. 5 carbons is going to be called pent. So it's going to be pentyl. Pentyl. Sorry, pentyl. Pentyl. And then this other one is going to be 1, 2, which is going to be meth. Pentyl methanoate. So the first, this chemical compound is called pentyl methanoate, right? So the chemical compound here is pentyl
Right?
methanoate. Yeah.
Isn't it eth?
What?
The other branch, the
Yes.
2 branch. Isn't it eth? He said myth.
I said meth. Yes, it's it. Thank you very much. Right? It's it because I've got 2 carbons. Thank you very much. Is it Rusani?
Yes, sir.
Okay. Pentyl ethanoate. Yes, it's not meth. Meth is 1. All right. Meth is 1. And then because it's 2 carbons, it means it's ethanoate, right? So thank you very much, Rusani. So that is our chemical compound is pentyl ethanoate. So now I can say I've given you all the names. Now we can name our hydrocarbons easily. So you can see that if you were not here since we started, we did everything. This is where we started. We started by this one and then naming them, and I was explaining everything. So this way we were still on hydrocarbon, and then 1 is meth, 2 is eth, 3 is prop, 4 is but, 5 is pent, 6 is eggs, 7 is what? Okay, 7 is hept, 8 is oct, and then we've got alkane. We see them by one bond, alkene, double bonds, alkyne, triple bonds, and then after that we've got butane, but1 y in, and but2 in, and then like forth, right? So we've done all these things. We've done all these things. And then now I can say we are done with naming. So the next thing is going to be chemical, what do you call this? Chemical properties and physical properties, and then reactions, right? We are going, in fact, we're going to start with reactions so that we can go to physical properties, right? So, but now I need us to understand how to name these things, right? Let me go to fast, because I will show you how the questions will come. Like, where am I going to get that document? Am I going to get it anytime soon here? In fact, I should, right? I should get it in. Yeah, it is. This is paper one. This is paper one. I needed paper two. This is paper one. Yes, this is paper one. I needed paper two. I needed paper two. Is it okay? So was paper one. I needed paper two. Am I going to get it here? If I don't get it here, I'll just, okay. This one is paper what? Paper two. Yes, it is. Okay. So you can see that the first questions here, they will be asking you to name the chemical compound. You see, they just given them to us, and then they give a first one. They say trimethylhexane, 2.4.6 trimethylhexane. Oof, I forgot one thing. So it means that I'm going to look at A, B, and F. A, B, and F. There is one thing that is very easy that I forgot. Okay, after this question, I will look for a few ones, then we can come to C, because C there, I never talked about C. I never talked about C there. That is the only thing that I had forgotten. Yes, I did forget it, yes, but I need to fix it now. Okay, but firstly, let's look at this one. Let's look at this one. It went up there. Okay, or in fact, let me just add something. All right, so we talked about hydrocarbons, alcohols, ketone, aldehydes, carboxylic acid, and esters. All right, we talked about esters also. So now there's one thing that I didn't talk about. It's a what do we call them? We call them aldehydes. I forgot about aldehydes, right? Aldehydes. Aldehyde, not aldehydes. Aldehyde, we talked about them. I wanted to say halogens. Yes, I forgot about halogens. Halogens. Guys, do you know what are halogens? Do you know what are halogens?
Are
Yes,
those elements that stay in group 7?
it's group 7, right? Yes, elements in group
Yes.
number elements in group number 7. I'm just looking for any chemistry question paper. Any chemistry question paper, science clinic. Okay, so even here we should have a periodic table. I'm just looking for periodic table here. There is no way that there is no periodic table here. Periodic table, those are the elements on this group. Those are halogens on, yes, here it is. So halogens are these ones. These are halogens. All right, these are halogens. Here are the halogens. So halogens, we've got, here are halogens, right? So we've got fluorine, chlorine, bromine, iodine, all right? And then 80, they don't bring that one. They end it at iodine, all right? So it's fluorine, chlorine, bromine, and iodine, all right? So those are called halogens, all right? So halogens, they've got halides, halides. So the halides is going to be what? It's going to be, the first one is going to be number 1 with 1 carbon, and let's say we've got Br here, and then like this. All right, so this is a halogen. All right, this is a halogen. All right, so it's going to, Br is a halogen, so this is a this is going to be called 1 carbon, and then because it's 1 carbon is meth. All right, so it's going to be meth. All right, that's a parent chain. All right, meth. All right, so it's going to be meth, and then doesn't have any double bonds, so it's going to be methane, but we have to name that it is as a bromine. So if it's a bromine, we call it a bromomethane. So this one's going to be called bromo. It's going to be called bromomethane, right? This one's going to be called bromomethane. So this is our bromomethane, all right? And then we have got 2 carbons, and then let's say I've got a iodine, chlorine. They like chlorine and bromine. Yes. So here it is. So this one is going to be called, because it have got chlorine, so it's going, and then we've got 2 carbons. 2 carbons is it's not meth, is eth. All right, it's going to be ethane. All right, so because it's 1, so it's going to be chloro on carbon number 1, so we can just call it number 1 chloro. All right, so it's going to be chloroethane, 1 chloroethane. All right, 1 chloroethane, 1 showing that the position is of chloro is on position number 1. All right, so and then we can have 1 2 3, then here we can have our iodine. Here it is. Here it is, right? So this one is an iodine. So iodine, we call it an iodo. All right. So this one is going to be, the iodine is on carbon number 2. All right. So it's going to be 2 iodo. Then because it's 3, function, the 3 is prop. All right. So it's going to be 2 iodopropane. Right. So it's going to be 2 iodopropane. All clear?
Yes, sir.
Yes, so that is our functional group. And then now let's look at the question that I had given. So this one here, so it means that now we've included everything, right? So the first one, they say 2.2.4 trimethyl. So we've got methyl. How many of methyl? 3 of them. On what? On hexane. So if they want us to draw a structure for that one, the parent group is going to be hexane, right? The parent group is going to be hexane. So I'm going to draw my hexane. So it's going to be hexane, which is 6 carbons, right? 1 2 3 4 5 6 2 4 6. So it's going to be 2 4 6 2.2.4 trimethyl hexane. So it's on the other one, the methyl is on number 2, and the other one on number 2 again, the other one on number 4. So number 2 is this one. So I've got a methyl. All right, and then another methyl is on number 2 again. So there is another methyl, and then 3 4, and then the other one is here on number 4. All right, and then that's it. All right, that's it, right? Okay, there it is. So it means that now we can put in our hydrogens, right? We can put in our hydrogens. So when we put in our hydrogens, the hydrogens are going to come here. The hydrogens are going to come here. The hydrogens are going to come here. So there it is. So if I have to draw that one, there is my structure. So the first thing that I had to look at was my parent chain. My parent chain is how many carbons? The parent chain is, the parent chain is how many carbons? The parent chain is 6 carbon hexane, right? So that was the parent chain. And then we had 3 of what? 3 of methyl on position what? Position number 2 and position number 2, then position number 4. So that is our structure of 2.2.4 trimethylhexane. So there it is, right? So there it is. I forgot the hydrogens there. I forgot the hydrogens there. All right. So there it is. That is our okay, and here I forgot to show them. That is fine. So there we are. So that is our 2.2.4 trimethylhexane. All right. And then now we can go to this one here. This one here, guys, is called a condensed structure. All right. This one is a compound name, right? This is an IUPAC name, all right? And then this one is called a condensed structure, all right? This one is called a condensed structure. What's going on here? So this one is called a condensed structure. Okay, I think I'm freezing out. I don't know why. Okay, so we've got a condensed structure. This one at B. B is the condensed structure. C is the structural formula. F is again there. It's again there. F is what? F is again the what? F is again there. What do you call this? F is what do you call this? At F is pentan 1 is a IUPAC name. All right. So now we need to talk about the condensed structure. All right, now we need to talk about the condensed structure. So let's talk about this condensed structure. What does it say? It means that the first carbon have got 3 hydrogens, right? Okay, well, sorry for that. So I've got 3, first carbon have got 3 hydrogens, and then the second one, it have got 2 hydrogens. So the second carbon have got 2 hydrogens, and then the third one have got 2 hydrogen also. Third one have got 2 hydrogen also. Third one have got 2 hydrogen also, and then the fourth one, 1, 2, 3. The fourth one have got 2 hydrogen also. The fourth one have got 2 hydrogen also, and then 1, 2, 3, 4. The fifth one have got 1 hydrogen and 1 oxygen. The last one have got 1 hydrogen and 1 oxygen. So let's assume that it was OH here. So if it was OH, you see, there will be 2 hydrogens missing. So it is not OH, right? So it cannot be OH because the first carbon will be missing 2 hydrogens, right? So it means that it's going to have what? It's going to have, I don't know why it is running that much. I don't have a pen now. So it means that 1, it was supposed to be a, okay, 1 was supposed to be a what? 1 was supposed to be a 1 was supposed to be a OH, right? A double O, and then the other one is H. So now you can see that everything there is complete. So it means that structure, that condensed formula is for the, it's not for ketone, it's an aldehyde because the O is at the end. So if we are to name this aldehyde, it's going to be 1, 2, 3, 4, 5. It's going to be pentanal, right? So this is pentanal. Number 5 is going to be an aldehyde, which is a pentanal. All right, and then this one here, C, is going to be a halogen, right? It's a halogen, and then it's going to be a halide. So it's going to be 1 2 3 4 5 5 1 2 3 4 5 5. You can see that the longest chain have got 5 carbons, right? The longest chain have got 5 carbons. So it's going to be 1. Okay, it's going to be 1 2 3 4. It's going to be 1 2 3 4 5, or it's going to be 1 2 3 4 5, right? So those are hydrocarbons, right? Those are hydrocarbons. So this one is going to be what? This one is going to be halogen, because we have got 2 halogens there. All right, we have got 2 halogens there, and then we've got a branch there. All right, but our functional group is this one. Our functional group is not a branch. Yes, sometimes we start closest to the branch, but when we got a functional group, we start closest to the functional group. So this time our functional group is an halide. All right, so if we are to name this hydrocarbon, what what do we call this? This organic compound, not hydrocarbon, because there's chlorine and bromine there, which means that it's not a hydrocarbon. All right. So if we are to name this compound, we are going to start by by B. Obviously, we're going to start here at the end there. We're going to start naming. We're going to start at this point, right? So this was going to be number 1, 2, 3, 4, 5, because if we started at the beginning here, or if you don't want to put that one as 5, we can also put 5 here. It's the same thing. All right, so this is our branch. If that's the matter, then that is our branch. All right, that is our branch. So it means that this one here is number 5. Sorry, it's number 5. Yes, so there is our branch. Our branch is methyl. All right, but the parent chain is 1 2 3 4 5 2 4 5. The parent chain is pentane. All right, so the parent chain is pentane. So that is the parent chain. The parent chain is pentane, and then we've got a bromo and chloro. So between a bromo and chloro, obviously we do alphabetical order. So it's going to be bromo. Bromo is on carbon number 2. So it's going to be 2 bromo, 2 bromo, and then 3 chloro, right? And then the branch, which is methane, right? Methane, the branch, which is methyl, right? Yes, it's methyl. Methyl. All right, so we have to name it as one thing. All right, so alphabetical order is going to be bromine, chlorine, and then methyl, because this is the parent chain. Parent chain has to be at the end. So the name of this organic compound is going to be okay, so let me see. Okay, the name of this organic compound, let me just use a red and try to write it right here. Okay, so it's going to be, I'm going to start with bromo. Bromo is on position number 2. So it's going to be 2 bromo. And then chloro is on number 3. So it's going to be 3 chloro. And then 2 bromo, 3 chloro. And then methyl is on position number 4. And got 4 dash again. Remember, between a number and a letter, there should be a dash. Chloro is methyl, right? Methyl. And then 2 bromo, 3 chloro, 4 methyl, and then the parent, which is pentane. So that is the name. It's 2 bromo, 3 chloro, 4 methyl pentane, right? So that is the IUPAC name of that compound. All right, so that is the first thing that I need us to understand. And also this one is called pentan 2,1. The one with that ends with 1 is a ketone. So if we are to draw a structural formula of this one, pent, I will start considering that it's a pent. Pent means that I've got how many carbons? I've got 5 carbons. right? Pent means I've got 5 carbons, 2, 4, 5, and then the ketone is on carbon number 2. So on carbon number 2, I've got a ketone there. So there it is. So all here that I didn't put anything is our hydrogen. So there is our pent 2 1. All right. So those are the kind of questions that they will start asking us. You can see here on the document that I've just opened, it is. You can see here the first questions they will be asking us about those things, all right? About those things, whether it's an alcohol, alkaline, or what. Okay, so let's go through. This was our question. Yes, the first one they say, write the letter that represent the following. An aldehyde. So aldehyde, we agreed that the aldehyde, we found that this one is an aldehyde because it ends, the B is an aldehyde because it ends with the O group, all right, with the functional group of O, and then doesn't have OH, otherwise it is going to be an a carboxylic acid, and then O is not in the middle, otherwise it was going to be a ketone, but it's an aldehyde because O is at the end. So number one there, we're just gonna name B. And then they're saying a condensation polymer, we didn't do polymers, is fine, is something else for the other D. So let's go to 1.1.3. They're saying a compound which has a carbonyl bonded to two carbon atom as a functional group. Carbonyl is O, all right? Carbonyl is O, all right? Carbonyl is O. Is O group. The carbonyl is this one, is the one that we talked about. This is the carbonyl. Let me show you the carbonyl. The carbonyl is this functional group. Where is the carbonyl? So this is the carbonyl, all right? This is the carbonyl. Is there ketone? Remember, ketone and aldehyde, they both have carbonyl. All right, they both have carbonyl. It's just that for aldehyde, the carbonyl group is bonded with H. All right, but here the carbonyl should be bonded with C both sides for ketone because O is in the middle. All right. So when they ask us here, they wanted the carbonyl the one that bonded with carbonyl, which is in the which is in the middle. They said in what? They said a compound which has carbonyl group bonded to two carbon atoms as its functional group. So they wanted an ketone, all right? They wanted a ketone. Yes, ketone is F. So the answer there was just going to be an easy F, all right? Ketone is a carbonyl group bonded to two carbons, no hydrogen, all right? And then now we can go to the next one. They're saying write down the IUPAC name of compound C. Where is compound C? Compound C, we talked about it. It was 2 bromo, 3 chloro, 4 methyl pentane. All right, that was the name of compound C. So you can see that is 3 marks naming that one. And then they're saying the monomer of compound G. We haven't talked about monomer and polymers. We'll talk about monomers and polymers later. All right, we'll talk about monomers and polymers later. All right, and then they are saying so I write down the structural formula of compound A. Compound A, we draw the structural formula. We started with the hexane, 6 carbon chains, right? And then the branches is the methyl. How many of them? 3 of them. We can see they said tri, which means it's 3 of them. The other 2, they are on the second carbon, and then the third one will be on the fourth carbon. So number A, we have answered it also. So you see the structure was going to have 2 marks, and then the compound F, we did it, which is pentan 2,1. It's just it was just a pent 5 carbons in a row, and then at the second carbon we've got a carbonyl group, an O group. All right, and then they're saying the table contains compounds that are functional isomers. We haven't talked about isomers. We'll talk about them later. But what I wanted you to see is that through what we have done, you can answer some questions, right? Like for this one here, the compound A here, I can name it. The compound A here is a hydrocarbon, and then it have got a double bond, is an alkene, and then with a branch. So alkene with longest chain with 3 carbons, so is prop. So it's going to be the parent chain is going to be propene, and then we've got a group at the second carbon. All right, so it's going to be 2-methyl propene, right? 2-methyl propene, right? So it's going to be 2-methyl propene. And then if you want to mention that in is on the function is on the first carbon-carbon bond, you can just name it 2-methyl prop 1 in. All right, so that is also fine. And then the second one is methyl butanoic acid. Oic acid is a carboxylic acid, so is butanoic acid. Butanoic acid is the parent chain. Butanoic acid is a parent chain, so it means that the first thing is 4 carbons in a row, and then on the last carbon I've got O and OH. All right, I've got O and OH. It's an alcohol and carbonyl. All right, so it's going to be like that, and then we've got a branch of methyl on the second carbon. All right, so that's it, and then we are done with that one. And then this one here, the last one here, C is what? C is also an it's a ketone, because we can see that carbonyl group there is bonded with 2 carbons, so C is a ketone. This is a ketone because you can see that the carbonyl group here is bonded to carbon with 2. Where is the pen? Okay, you can see here. Okay, okay, so let me just rub here and make sure that here is black is or red. Okay, you can see that here is a functional group, is a carbonyl group, and is bonded with this carbon and this carbon, so it's a ketone. All right, the parent chain is a ketone. So if we are to name that one, you can see the longest chain, not, it looks like it's this one. So here they combined a structural formula and what, and condensed formula. Yes, this is a condensed formula. So you can ignore this condensed formula and think about it as if it is like this, right? So let CH2 and CH3, right? You can think about it as if it is CH2 and CH3. So let's try to do it like that, right? Let's try to do it like that. Okay, I'm going to rub it and make sure that it's CH2 and CH3, right? So you can work it as if it was like this, right? It's CH2, so I've got H here, and then I've got H here, and then I've got C, and then I've got H. See, CH2, CH3. Yes, CH2, CH3. So you can see that the longest chain is going to be this chain here. All right. So that is going to be our longest chain. So the longest chain consists of how many carbons? 1, 2, 3, 4, 5, 6. So it's 6 carbon, and then it's a ketone. And then when do we start counting? We start closest to the functional group. So if we start here at the bottom, it's going to be 1, 2, 3, 4. It's going to be on number 4. But if we start counting here, then it's going to be on 1, 2, 3. It's going to be on number 3. So it's going to be on 3. All right. And then we know that ketone ends with 1. All right. So the parent chain is going to be 1, 2, 3, 4, 5, 6. 6 is hexane. And then the ketone is on number what? 1, 2, 3 is on number 3. Hexane 3, 1. Right, it's going to be hexane 3, 1. So that is for the parent chain. And then we have only one branch, right? We have only one branch, which is a meth. It's on carbon number 4. All right, so it's going to be 4 methyl, 4 methyl, 4 methyl hexane 3, 1. All right, it's 4 methyl hexane 3, 1. So that is our name. All right, that is our IUPAC name. Are we clear?
Yes, sir.
So that is
Yes,
our,
sir.
okay, so that is our IUPAC name. And then we've got but 2 in. In is just a is what do we call this? Is a hydrocarbon, but with a in, it means that we have got a double bond. Where is the double bond? On carbon number 2. All right. So it's going to be but is 4 carbons, 1, 2, 3, 4. All right. So this is carbon number 1, and then carbon number 2 here, and then here. All right. So there it is. So there it is. There is our butan 2 in. All right, there is our butan 2 in. That is the structure of butan 2 in. And then we've got this one again. You can see CH2 and CH3. I told you that you can replace it with this, something like this, right? This is just a condensed form. All right, so it means that we have got C with two H's and then C with 3 H's there. All right, so it means that if we are looking for, and then this one, you can see that it's a branch, it is supposed to have 3 H's there. Right, so this is the combination of a structure and condensed. All right, so the first thing, if we are to name this one, I'm going to look for the longest chain. Longest chain for me is going to be here. All right, it's going to be 1, 2, 3, 4, 5, 6. So there is our 6 carbons. All right, and then you can see that here we're going to have 1, 2, and then on the third one, that is where we're going to have a branch. A branch is going to be this one here. All right, so it means that but if we start counting, it's going to be 1, 2. The branch is going to be on the second one. So it means that I'm going to name this one 1, 2, 3, 4, 5, then 6 carbons, right? So the parent chain again is going to be hexane. I don't even have a double bond. So the parent chain is just going to be a simple hexane. All right, there is no double bond. And then the branches, I've got the branch here. This is the branch. This is the branch which is a eth, right, which is a ethyl, right? And then this is a branch here which is a meth. This is a branch here which is a meth, right? So those meth are on number 2. So I've got 2.2 methyl, 2.2, 2 and 2, okay, between meth and eth. Which one starts? The one that starts between meth and eth, the one that starts is eth. All right, so um eth is on number 4. So I should have started with that one because I have to write my things in alphabetical order. I should have started with eth. So it's going to be eth on number 4. All right, I should start with eth on number 4. It will be 4. Then 4 ethyl. Okay, if I try to write too quick, ethyl, 4 ethyl, and then dash, and then 2.2 di, because there's 2, right? I told you that di means 2. So there's 2 of what? Of methyl, right? 2 of ethyl, of methyl, yes. Methyl. So there is the name. The name is 4, and then 4 ethyl, and then 2.2 dimethyl hexane. So that is the name of compound number D. And then F, that's when we talk about polymer and monomers. I'm not here for that. All right. And then now they are saying, name the functional group of B. Where is B? B is an oic acid. Oic acid is a carboxylic acid. That is the functional group. Right? Oh nope, they said the functional group. The functional group is formally carboxylic butanoic acid is formally, yes, we haven't talked about those ones, yes, but I think it's formally, but I'll give you notes about that. Yes, it's formally. For carboxylic acid is formally, and then for ketone and aldehyde is carbonyl. Yes. Okay, homologous series, I don't want us to go there. Type of polymerization of F, I don't want to talk about polymers, I told you. So F, they're talking about monomers again. So 2.2, they want compound C. Compound C, we've talked about it, is what? Where did I write it? Compound C, it was 4-methylhexane 3 1. All right, that is our compound C. And then compound D, where is it? Compound D is 4-ethyl 2.2 dimethylhexane. Okay, and then now they are saying write down the name or formula of each product formed during the complete combustion of D. Complete combustion, we haven't talked about reactions. We'll talk about reactions later. And then they want write down the structural formula of compound B. Where is B? B, okay, there it is. I didn't throw this one. Is butanoic acid, oic acid, and then 5 is 4. So it's going to be 1, 2, 3, 4. Right? And then at the last one, because it's an oic acid, the last one is going to have OH here, OH, and then O here, there it is. So this one is just a oic acid, right? I've just write an oic acid, butanoic acid, but there's a methyl branch on carbon number 2. There's a methyl branch on carbon number 2. So there we are. So there we are, right? There is our methyl butanoic acid. Out clear?
Yes, sir.
Do you think you can do this? Do you think you can do this on your own?
I'll try.
You can try, né? Okay. But I hope we've done a lot. Tendo. This is a very important topic, right? But I'm going to send you some videos of what we have done so far, right? I'm going to send you some videos of what we have done so far. But for now, let's end it here. All right, let's just end it here. I just wanted you to understand the structures, the name. Yes, it's a structural formula, condensed formula, and then the naming. Those are the three basic things that I need us to understand, right? I think in all the 3 or 4 videos that we have done, we have been doing that, right? We have been doing that, right?
Yes.
Sure.